Hi everyone, it is Sridevi, Professor, Department of Electronics and Communication Engineering, Rohini College of Engineering and Technology. In this video, we are going to learn about flat top sampling. On completion of this topic, the learners can understand why sampling is required and the basic concepts of flat top sampling. Before getting inside the topic flat top sampling, one should know about the basics of sampling theorem. This theorem states that a band limited signal of finite energy which has no frequency components which is higher than W hertz is completely described by the interval separated by 1 by 2 W seconds. So in flat top sampling, the top of the samples remain constant and it is equal to the instantaneous value of modulating signal. That is why it is called as flat top sampling. Thus, the amplitude of pulse after sampling is kept constant. So that is why the top of the sampled signal remains flat, hence it is called as flat top sampling. So after sampling, the signal which is obtained is called as flat top sampled signal. So to get the flat top sampled signal, we have one circuit like this, that is, so x of t is the input signal and g of t is the output signal. So input signal we are giving as the continuous time analog signal, and g1, g2, these two are the FET circuits. So they will act as an sampling switch. G1 is act as sampling switch and G2 will be act as discharge switch. When capacitor is there, it will charge in between T1 to T2 seconds, and Ts is the sampling time that is represented as 1 by Fs. So the flat top symbols are represented like this. See, x of t is the continuous time signal and g of t is the pulse. So the flat top sampled signal that is represented as sample and hold circuit output. So sampling is that is the time which is known as is capacitor charging time, and after that it is hold and finally it is discharged. The duration or width of each sample is represented by tau and the rate is equal to Fs. Fs is that is given by 1 by Ts. This circuit, sample and hold circuit, is used to sample and hold. After that we can get the flat top sampled signal. So the spectrum of the generated flat top signal is determined as the continuous time signal x of t and pulse as c of t, and x of t and c of t both are multiplied, and finally this flat top sampled signal is the output. And the switch is when we are getting the final output is when the switch S1 closes at each sampling instant of the modulating signal. This at the time the capacitor C holds the sampled voltage at the time period tau till the end of the switch S2 is closed in another discharge time of the capacitor. Thus the signal generated as the result of sample and hold process is called as flat top sampled signal. So in flat top sampled signal, the top of the signals are flat. So during sampling time, it is done by sampling and hold process that is done by the capacitor. So the flat top signal is obtained as like this. Yes, del of t is the impulse signal that is convolutional with h of t is the unit pulse. So both are convolved and get the h of t, that is the instantaneous sample pulse h of t. So g of t is nothing but g of t is that is equal to s of t convolution with h of t. So s of t, that is convolution with h of t, gives g of t. So here the g of t is nothing but the flat top sampled signal. So here this del of t is the time constant, that is the delta function, where s of t is nothing but the time varying amplitude of train of pulses. Hence in flat top sampling we can get the sampled signal in such a way that convolution between these two signals. So x of t that is convolved with another signal which is same as that of the multiplication in time domain. So in frequency domain the convolution that is same as that of the in time domain, that is called as that is g of t is equal to s of t convolution with h of t. So this is nothing but convolution between these two signals will produce the final output. So according to this property, we can prove this g of t is equal to x of nts into h of n minus t minus ns. So final this output, we can get the flat top sampled output that is represented in both time domain and frequency domain. In frequency domain, it can be represented as g of f is equal to s of f convolution that is multiplied with h of f. So here thus the spectrum of the top signal is like this, g of f is equal to like this. So we can draw this spectrum like this. So here message signal s of t and final output like this. So here in flat top sampling, that can be mathematically considered as convolution of sampled signal and the pulse signal. So final the reconstruction of the sampled signal is like this, that is low pass signal, that three conditions: fs is greater than 2fm, that is some gap or some distance between them; fs is equal to 2fm, that is there is no gap it touches; and fs is less than 2fm, that is it overlaps, that is aliasing occurs. This is the quiz question based on flat top sampling, that is the instantaneous sampling. That has four options are there: has train of impulses, has pulse width approaching zero value, has a negligible power content, and all of the above. So this three concepts are applicable to instantaneous sampling. That is why final answer is D, all of the above. So here we learnt about sampling and sampling, flat top sampling. Thank you.